Okay, I want you to imagine something for me. You look up into the night sky, there's no moon, it's completely dark, and you know there's no lightning anywhere nearby.
Right.
But then you see it. High up, there are these clouds, and they're glowing, shining with this weird silvery blue light. It just looks impossible.
It really does. It's an image that immediately makes you think of something, you know, supernatural.
Yeah.
People mistake it for auroras all the time or something else entirely.
Yeah.
But what we're really looking at here, according to our sources, is some incredibly complex physics and chemistry happening way, way up high.
So the air itself is becoming a light source.
In a way, yes. The air, the molecules, the ice crystals, they're all part of this very sophisticated system of light.
Okay, let's unpack this. Our mission for this deep dive is to get into that world of high-altitude flight. We're looking at three main things our sources talk about: noctilucent clouds, sky glow, and this process called airglow. We really want to get to the why behind it all.
Exactly. We've looked at research that goes beyond the usual stuff like the northern lights. We're zooming in on these events that are honestly almost invisible most of the time. They happen right at the edge of space.
The boundary between Earth and everything else?
Yeah. We're basically uncovering how light gets reflected and sometimes even generated in the super thin air, about 80 kilometers over our heads.
This is where it gets really interesting for me. We have to start with the most famous of these, right? The NLCs, or noctilucent clouds.
The luminous night clouds.
Right, and the key thing about them, the thing that sets them apart from literally everything else, is just how high up they are.
That altitude is the whole puzzle right there. We're talking about clouds forming around 80 kilometers above the Earth's surface. That's not just high, it's in the mesosphere.
And just to give you a sense of scale here, the highest clouds you normally see, those thin, feathery cirrus clouds, they top out at maybe 16, 17 kilometers.
Right, and the official edge of space is just a bit higher, at 100 kilometers. So these NLCs are basically forming at the gates of space.
But wait, the most counterintuitive thing I read is that it's actually the coldest part of our atmosphere up there.
It is. Paradoxically, the mesopause, right where these clouds are, can plunge to temperatures below minus 130 degrees Celsius. It is the coldest place on Earth.
So if it's that cold, how does a cloud even form? I mean, I thought clouds needed warm, rising air.
And that's where the physics gets so fascinating. NLCs aren't made of water droplets like normal clouds. They're made of microscopic ice crystals.
Okay.
And to form up there, they need that extreme cold, but also two other really rare ingredients. First, you need a tiny bit of water vapor that's managed to drift all the way up. And second, and this is the key, they need something to condense onto, a nucleus.
And that nucleus is?
It's primarily micrometeorite dust.
You're kidding! Micrometeorite dust, like tiny bits of grit from space, are the seeds for these clouds.
That's exactly it. It's truly cosmic. These clouds are literally built on space debris, so you have this combination of space dust, ultra-cold temperatures, and a little bit of water, and that's how you get these incredibly thin, widespread ice clouds.
So you've got these almost ghost-like ice clouds floating at 80 kilometers, seeded by dust from shooting stars. That height is what lets them glow after sunset, right? How does that reflection work?
It's all about geometry. For you on the ground, the sun has set. The curve of the Earth is blocking the light.
Sure.
But if you're 80 kilometers up, you can see much farther over that curve. Those clouds are still high enough to be sitting in direct sunlight.
They're sort of standing on tiptoes just above the Earth's shadow.
That's a perfect way to put it. They're snaring that sunlight long after we're in darkness. And because the sun is so low on their horizon, it gives the clouds that signature pale, ethereal glow.
And what are the colors we typically see? I know I mentioned blue.
The sources are pretty clear on this. You're usually going to see one of two things. Either a really vivid, deep blue, or this beautiful, almost shocking silver or silvery color. It's just a brilliant reflection of that low-angle sunlight.
And is this just a cool thing to see, or does it actually tell scientists anything important?
Oh, it's a huge deal. Our sources point out that NLCs are now seen as key indicators for atmospheric changes.
How so?
Well, they were first really described in the late 1800s, but their frequency and brightness seem to be increasing, and we're seeing them farther and farther from the poles.
Which means...
It could mean a couple of things. One, that specific layer of the atmosphere might be getting colder, which sounds weird with global warming, but it's complex. And two, more methane might be reaching the upper atmosphere.
And methane breaks down into...
Water vapor,
Yeah.
the exact ingredient you need for more ice clouds.
Oh,
So yeah, their brightness is an unexpected, very high-altitude sign of climate change.
wow. So the seeds of climate change are being lit up by space dust. That's a lot to take in.
It is.
Okay, but that's reflection. Now we have to move into an even stranger area. Our sources talk about times when clouds, or just the sky itself, seem to glow with no reflected sun at all.
This is the big jump. We're going from reflection to self-illumination.
Right.
This is where we have to talk about the air itself emitting light, and we need to get these two terms straight: sky glow and air glow.
Okay, let's nail those definitions down.
Sure, so sky glow is kind of the umbrella term. It's all the natural light in the night sky, combined starlight, zodiacal light, distant galaxies. But a big component of that is air glow.
And airglow is?
Air glow is the main event here. It's light created by chemical reactions in the upper atmosphere. It's happening all the time, all over the planet, and it has nothing to do with the sun or moon directly shining on it.
That sounds absolutely wild. So molecules in our own atmosphere are just glowing. How does that even work?
Think of it like a giant planetary battery that's on a time delay. All day long, solar radiation bombards atoms and molecules like oxygen and nitrogen way up high. It pumps them full of energy, putting them into an excited state.
So they're charging up all day.
They're charging up all day, exactly. Then at night, with the sun gone, those molecules start to relax. And to do that, they have to shed that extra energy. They release it as photons, as light. That's airglow.
But if that's happening constantly every single night, why don't we see a glowing sky every time we look up?
That's the visibility challenge. The glow is incredibly faint. I mean, our sources say it's maybe as bright as a few hundred faint stars all smeared across the whole sky.
So your eyes just can't pick it up.
Not unless the conditions are perfect. You need zero light pollution, no clouds, and you really have to be looking at a huge patch of sky for your brain to even register it.
So when someone says they saw a cloud glowing in the middle of the night, it's not the cloud.
Not usually. It's the airglow behind the cloud. The cloud is just acting as a projection screen, gathering all those faint photons and scattering them, which finally makes the light intense enough for our eyes to see.
So the air behind the cloud is glowing. That's incredible. Okay, let's talk about the colors, because this is where the chemistry gets really cool.
It really does. The colors are basically a chemical fingerprint.
So green. What does green tell us?
If you see a green glow, that is almost certainly oxygen. Specifically, oxygen atoms reacting at about 90 to 100 kilometers up. It's the most common color you'll see in airglow.
And what about yellow? I read about a yellow glow too.
Right, the yellow glow comes from sodium. There's actually this thin layer of sodium atoms around 90 kilometers up, which comes from micrometeorites burning up. When those sodium atoms get excited and then relax, they give off that very distinct yellow light.
And scientists don't just look at these colors because they're pretty, right? They use them.
Oh, absolutely. Studying airglow is fundamental. The brightness and the exact shade of the light tells them what chemicals are up there, but it also tells them about the winds.
The winds. How?
If you see the light shifting slightly or moving in patterns, it tells you about the upper atmospheric winds. That's crucial for understanding space weather, how it affects satellites, things like that.
That is just a phenomenal application, using faint light from space dust to measure invisible currents miles above our heads. But the sources also mentioned some even stranger colors.
Yes, the really rare stuff.
Yeah.
So we've got green from oxygen, yellow from sodium. And every once in a while, people report a true purple or violet glow.
And that's exceptional.
Very exceptional. The sources say this color comes from a very rare reaction, maybe involving nitrogen oxides. It means there's a really energetic event happening, something outside the norm. It requires the perfect conditions.
What's kind of humbling, though, is that even with all this science, we still don't know everything.
Not even close. That's the reality of it. We can explain most NLCs and the main airglow colors, sure. But researchers have definitely recorded glowing clouds or patterns in the sky that have, well, no conventional explanation at all.
Like what? What would an unexplained event look like?
It might be a really localized flash or a strange structure that doesn't match any known chemical light signature. It forces scientists to think about other things, like weird electrical discharges or interactions with high-energy particles we don't fully understand. The atmosphere is chaotic.
It's a reminder that the sky is still holding on to its secrets. So for anyone listening who wants to see this, what are the tips? Where do you go?
The main thing is darkness. You have to get to very dark areas, far away from city lights. For noctilucent clouds, you need to be at high latitudes, near the poles, in the summer.
That's when the geometry is just right for them to catch the sun.
Exactly. For airglow, it's less about being near the poles, but
Yeah.
you absolutely need a moonless night and zero light pollution. Then you just look up, you might be lucky.
We have to talk about the feeling of seeing this, because it just breaks your brain a little bit. We expect night to be dark, inert.
Absolutely. When people see this, especially the bright NLCs, the first reaction is often that it must be supernatural. It looks like a ghost light hanging in the sky. It's unsettling, but also really powerful.
But then you learn the science that it's just sunlight bouncing off cosmic dust or oxygen atoms releasing stored energy, and it changes from spooky to sublime.
It does. And that's why our sources always end by calling them the most beautiful and strangest clouds on Earth. They're a direct link between our planet and the cosmos.
That's a perfect way to end it. So just to recap, we've got two main ways the sky lights up. First, the optical illusion of NLCs at 80 kilometers catching sunlight on space dust.
Right. And second, the actual chemistry of the air itself glowing. The airglow giving us those green and yellow chemical signals.
The big takeaway here is that the night sky is never truly passive. Even in total darkness, our atmosphere is this giant glowing chemical lab.
That's it. It's constantly recycling energy from the sun. It proves that energy is never lost. It just transforms into this silent, beautiful light.
So next time you find yourself in a really dark place on a moonless night, just look up. You might catch the Earth's atmosphere putting on its own quiet, luminous show, proving the world above us is alive with light, even when we think it's completely dark. Thanks for joining us for this deep dive.